Let's look at some exam questions regarding differential equations. The first one is this over here from spring 2014, paper 33. And the question is this question over here, question 5. It says the variables x and theta satisfy the differential equation 2 cosine square of theta dx by d theta equals square root of 2x plus 1, and x equals 0 when theta equals pi over 4. Solve the differential equation and obtain an expression for x in terms of theta. Okay. Let me get there. This is what you start with. All the information is here in green. So you have to solve the differential equation. Solving the differential equation means putting on both sides of the equal sign expressions that have the same variable. So it means putting stuff with x, so to speak, on one side and stuff with theta on the other side. The problem is that if you try to send this to the other side, you're not accomplishing that. Ideally, this dx would be in the denominator, and then you could send to the other side, and the theta would be over there. Well, you can just do that. Just invert the whole thing over here. Okay? If you invert the whole thing over here and do the same thing over there, obviously, basically divide both sides of the equation by divide 1 by what you have on both sides of the equation, will lead to this. And you know that 1 over cosine square of theta is the second square of theta, which you know how to integrate, right? Then I can send now the dx to the other side, and I have here an expression with everything in theta on this side, everything with x on that side, and now it's time to just integrate. I leave the 1/2 outside of the integral sign. You should know that this is just tan of theta, okay? And integrating this, you can use here a very simple change of variable. This is going to be u, so du by dx is going to be just 2, meaning that du equals 2 dx, or dx equals du divided by 2. So substitute dx by du divided by 2. This is just going to be u to the power of minus 1/2. I already sent the 1/2 outside as well, and I can cut it out with that over that. So this basically transforms into that. It's now time to make u again what it actually is, which is 2x plus 1. And now, in order for us to figure out the value of the arbitrary constant, we have to use that information. When x equals 0, the theta equals pi over 4. So this means that tan of pi over 4 equals 2 times square root of 1. That's what happens when you substitute x by 0. Plus c, so c is minus 1. So let's just update that. And we have here tan of theta equals 2 square root of 2x plus 1 minus 1. We need, as the question asks, don't forget, an expression for x in terms of theta. So we have to isolate x now. So let's just send that minus 1 to the other side, and also send this 2 to the other side. Get rid of the square root by squaring both sides. Then get rid of the 1 and the 2, and eventually you get into this, and it's solved. Another one. Winter 2014, paper 33, it's question 8. Let me just ensure that I'm doing the correct one. Yes, question 8. The variables x and y are related by the differential equation dy by dx equals 1/5 of x times y to the power of 1/2 times sine of x over 3. First question is, find the general solution giving y in terms of x. Okay, so you have this huge expression. Again, you solve this by putting everything with y on one side and everything with x on the other side. This implies moving this to this side, and it will become y to the power of minus 1/2. The dx goes to the other side. Now it's time to integrate both sides. I already pushed the 1/5 outside of the integral side, the integral sign on this side, okay? This is trivial to integrate, but this is not. You have to do integration by parts. This is a simple polynomial times a simple trigonometric function. So you use u as being x, du by dx is going to be 1. dv by dx is going to be sine of x over 3. So v equals minus 3 cosine of x over 3. We went through this in the previous chapter. So now just apply the rule over here. This is going to be equal to u times v minus integral of v du by dx times dx. So this part is just 2 square root of y. Now it's just algebra. No, I have to integrate that. So I can push the minus 3 outside, becomes plus 3. Integral of cosine of x over 3 is cosine of x over 3 over 1 over 3. So basically that multiplies with the other 3 and becomes a 9 plus e. And now it's just taking care of things so that I have y in terms of x as the question asks, right? Y in terms of x, yes. Now it's just algebraic manipulation. So this 5 goes over there, becomes 10 square root of y. Nothing else happens over here. I just flipped the position of those two. Get rid of the 10, dividing everything by 10. Get rid of the square root, squaring both sides. And here you have this long expression, but it's the one that you need. Then, given that y equals 100 when x equals 0, find the value of y when x equals 25. This piece of information will allow you to determine the value of the arbitrary constant. So let's use it. Okay, so y equals 100, x is 0, so just plug in. This will lead to a value of c of 10, so let's update that. That is going to be 10. Now, when x equals 25, plug it there, and you'll have here the value that you'll need, okay? Don't forget that this value over here is in radians. Last question. Winter 2013 question paper 31. This is the most interesting because it relates to a real life situation. Okay. A tank containing water is in the form of a cone with vertex C. The axis is vertical and the semi-vertical angle is 60 degrees, as shown in the diagram. At time t0, the tank is full and the depth of water is capital H. At this instant, a tap at C is opened and water begins to flow out. The volume of water in the tank decreases at a rate proportional to square root of h, where h is the depth of the water at time t. H lowercase h, you have two h's, don't forget. The tank becomes empty when t equals 60 seconds. So before actually reading anything that you need to answer, let's translate all of this into math. What is the capital H? The capital H is the total height of water at the beginning. So it's this value over here. You know that you have this angle over here, 60 degrees. So at some point you have to make sense of this, but I'll get that in a bit. You are told also that the rate at which, let me get the exact wording. The volume of water in the tank decreases at a rate. Okay, so dv dt equals what? Is a decrease, so it's minus proportional to square root of h, so minus k square root of h. This is what you get, right? And you know that when the time is 60, the tank is empty. So what does this mean? This means that this h is going to be 0. And you know when time is 0, the capital H is going to be, no, sorry, the H is going to be equal to the capital H. H is the depth of water at any instant. When the tank is full, that is at time 0, this small h equals to h, which is the full depth of water. That's what I wrote over here. Actually, I didn't put this in terms of the capital H. I just wrote that the volume is 0. I probably don't need that. Anyway, let's look at the question now. Show that h, the lowercase h, and t satisfy a differential equation of the form dh by dt equals minus a h to the power of minus 3 over 2, where a is a positive constant. Okay, so let's look at what we have. We have an expression for dv dt. We want an expression for dh dt. So what we need to use? We need to use something that we learned last year, which is the chain rule. And we know, I should have started over here. I wrote it, this stuff first, but this should be the first part. dv by dt equals dv by dh times dh by dt. Right? You want an expression for dh by dt. This is what you want. Eventually, you need to reach that. This is the thing that you have. So you need to calculate dv by dh. Remember this from last year? So this is a tricky part. You have to get an expression for v in terms of h. What you know about the v? The question actually tells you at the end. The volume v of a cone of a vertical height h and base radius r is given by v equals 1/3 of pi r squared h. This is actually part of the MF19, as you can see here. Okay, base area times height. The base area in this case being a circle. This will give you a hint on what you have to do because you are introduced to a new variable over here, which is the radius. The radius is what? Is the distance that goes from here to here. Right? So the volume equals 1/3 pi h r squared. How are you going to get rid of that r? Putting this in terms of any other variable that you want, particularly h. Well, you know that this angle stays the same. And what is this angle? You can relate this angle to the h and the r. You know that the tangent of 60 is going to be the opposite side of this triangle. You can see here the r over the h. Right? So the r is just h tan of 60. Make sense? So you have here r squared. So instead of writing r squared, you can just write h squared tan square of 60. But you have here another h, so you actually have h cubed. So this will become tan square of 60 pi h cubed divided by 3. And now you are able to differentiate this in terms of h. dv by dh is going to be, this is just a constant, right? Is going to be, well, and tan of 60 is just square root of 3. Is just going to be this value over here that after simplification will turn into, I'm a little bit lost. Yeah, no, I ended here. So this is just going to be 3 pi h squared. Okay? So dv by dt is that. I plug it here. dv by dh is what I just said, 3 pi h squared. dh by dt is the thing that you want. So let's isolate this as the question asks, sending this to the other side. All right. So dh by dt, now I can simplify this. This is just h to the power of minus 3/2. And the constant a is just going to be the constant a is just going to be k over 3 pi, which is a positive constant as it was required. All right? This is that. Now, solve the differential equation given in part 1 and obtain an expression for t in terms of h, small h, and big H. Let's now solve this. All right, so you have here an expression in terms of lowercase h. You have to get rid of that t, sending to the other side. Don't forget that a is a constant. We already know what it is. Okay, so all of this goes to this side. The dt goes to the other side. I can simplify this and write it like this. Now it's time to integrate both sides. Don't forget again, a is a constant, so it can stay outside of the integral sign. I just have to integrate that in terms of h and integrate this. This is just t, obviously. And then you have minus 1 over h to the power of 5 halves divided by 5 halves, or multiplied by 2/5. And now I can use the conditions that I was given in the beginning. And I know that at the beginning, at time 0, the lowercase h equals the uppercase h. After all, I have to use this. Okay, I didn't write it at the beginning, but I have to use it. So I can substitute the 0 over there, the capital H over here, simplify, and I get an expression for C and A. Don't forget I have two unknowns to find, C and A. The other piece of information is going to give me the second equation that I'll need. When t equals 60, the h is going to be 0, the lowercase h is going to be empty, right? So again, I'm now going to substitute h by 0 and t by 60 and solve it, and I'll find c is going to be 60. Okay, so combining these two, I can substitute the 60 over there and solve it for a. And a is just going to be h, capital H, to the power of 5 halves over 150. So I can update that equation in terms of t, which is going to be minus 150 over h, capital H, to the power of 5 halves. That comes from there. Times that stuff, plus c, which is 60. I can simplify further because I have 2 things to the power of 5 halves, so I can put it as a single fraction with the same power. Okay, this is just 60, the result of multiplying 150 times 2, that's 300 divided by 5, that's 60. You still have that minus, so minus 60 plus 60, and now I can factorize the 60, and this is the expression for t in terms of lowercase h and uppercase h. The third part is the simplest one. Actually, it's just 1 point. Find the time at which the depth reaches half of the original height. We already have everything set up. It's just substituting. Okay? You want a time when h equals this. So where you have lowercase h, just plug in uppercase h over 2 and solve it. The uppercase h is going to cut out, and eventually you get this time 49.4 seconds.